But I will try also to be kind of balanced in the presentation and also show a number of problems you may encounter while you try to listen to adopt and use more of the typing. Okay. So we will be both presenting and then. Yeah, better, right? So I will try to present both the advantages, things that will help you, and things that will be, hidden traps that probably will be mean to you and be a problem when you try to work with them. One thing that's really nice with TYPEHINT at the moment is, generally speaking, it has been evolving a lot since the beginning, I guess, but it has been evolving a lot, so there are new things coming up with every new version, so we will start with a little review. So make sure everyone are on the same level, and we can remove everything that is rumors about things that do not exist yet, but that will be coming, or maybe not, because it's still under discussion. And then we will take a look at TYPEHINT and the effect on two different things, which are around one border. This is the method signature. By method, I mean functions, closure, whoever is supporting TYPEHINT. So we will do one part on what is the impact of TYPEHINT inside the methods by the fact that you're using them as argument on the arguments and on the return value. And then we will also work on what the impact of the TYPEHINT on the system by itself. Where it will be changing orders and classes priorities as an application. So that's the systemic approach. Okay? First the review, then inside, then outside the method. That will be more complex. So where do I get this information? Well, I'm working as CTO on a static analysis engine. Static analysis engine just love TYPEHINT. Okay? We don't understand exactly what's happening whenever you're throwing something into a function, and we have just no clue of what it's doing except the name, and even at that, the name is completely random and arbitrary. With TYPEHINT, at least we know what's coming in, so we can do extra checks. Okay, so that's why I actually spend a lot of time working on those. I also, as you can see, do a retirement home for elephants, where I have the patriarch here, and we've got also the very young elephant, so that's another of those evolving technologies with PHP, which is really nice to follow. So TYPEHINT, we just skip if you know everything, but I'm pretty sure that there will be a few information that are recent. So TYPEHINT in PHP, quick review. They are the thing that is on the left side of the argument when you are writing a string, a signature. Okay? Oh, nice. So if you're looking at a TYPEHINT on the right side, it's wrong. It's a default value, completely different. Okay? But on the left side, then you have them here, and at the end, the return type of the function, which means that not on the argument, but the way what the function or the method will return will be after a column, and it will also have a name. We will use different things. Most of the time, strong TYPEHINT means classes and interfaces, so you can have them here, that are also under the spell of the use, so you can actually use aliases to change the name and make them really short inside the definitions. Okay, simple work. And then we've got the actual code behind that. Now, there are other ways and other places where we can start seeing TYPEHINT. In particular, if you're already working or trying to work with PHP 7.4, we will get the properties that will get a TYPEHINT. It works the same, as arguments. It means that you cannot put anything else than a user object in that property. And it will be checked at execution time. Okay? You will actually start with the default value, but until the property will be assigned with a first value, it will just be completely inaccessible. You will probably run into that a lot when you decide to adopt TYPEHINT properties, because basically you cannot put a default value except a null, which is of course completely useless. But until you actually have an assignation from the constructor, from a getter and setter, then you will have no access to the property. Then you can do whatever you want, change it and put other values. There are some rumors about getting variables, local variables with a TYPEHINT, but it's just that, a rumor. Okay, I'm pretty sure there are a few people trolling us about that. because of course we have absolutely no declaration for local variables, so we don't know where to put that. So at the moment, if you see them with variables, it means that it's a PHP doc for the static analysis, meaning that it's outside PHP, and we're not going to talk about that. Okay? Easy up to there, right? Okay. What can we put as TYPEHINT? Well, there's a lot of things and lots of categories. The simple one and the first one we have here, scalars. Boolean, integer, floats, do not use real because in 7.4 reals are gone. There's no more real, just floats. So just use floats here, string and object. Object is slightly different from the class one because object just means one object, whatever the class. Okay? On the other hand, the class means an object and that specific class, so it's a little more precise. But those are the default ones. There are some extended ones which are covering the world between the classes and the scalars, which are in particular iterable and callable. So iterable will cover everything that you can basically throw at the for each statement. That means an array, of course, a hash, a map, whatever is called with the array syntax in PHP. But that also means every class that actually implements the array access interface. Okay? Instead of having two checks and saying I accept arrays, or I accept array access, or I accept also generators, then you can actually use iterable and everything will do inside. Callable will be covering everything that's a nested callback. And you know in PHP we've got a wide range of possibilities. Strings, arrays, class, syntax class, double column and class and stuff like that. You've got lots of ways to declare and address, reference a class. So callable would be that. Anything you can call would be under that typing. Interfaces and classes, we've already covered that. Simple enough, except there are some specific things. Traits cannot be used. So if you want a trait and the trait to be recognized as something special, then you have to make an interface from the trait and then check the interface of the trait. No use for traits as TYPEHINT. They are completely different. They're like a big copy and paste for classes. You can also use self and parent. Self representing the class itself, even if the name changed. So it's kind of convenient. And parent will represent everything that's above the current class. Parent, grandparents, great-grandparents, and stuff like that. Okay? You cannot use static because static will be solved at execution time and TYPEHINT is compiled. So static will not be available. You cannot use static as a TYPEHINT. And I will finish with, well, we will work on the last line says mixed resource numeric. Those are available, I mean, they are already reserved PHP keyword, they are just not enforced. So you can currently create a mixed class that will be a TYPEHINT until PHP decides that it really wants to make use of that, and then you will be out. Okay, so you have to. So just don't prepare for them, but don't actually use them, they're not available. Finally, there's this really weird one, and we're going to have to work a little bit harder on those ones, array, void, and nullable. So nullable is actually the last kind of special type we have here, right? Boolean, int, float, string, object, those are PHP types. Null is one of them, except that null is very special, because what would that mean if you decide to type an argument as null? Well, there's just one possible value, right? Which is null. So, of course, the easiest way is just get rid of it. So you could actually type it as null or decide to have it with another value, null or an integer, null or an object of that class. Then we've got this special thing that has a question mark you add on top of the others. So it's kind of a very special situation for null in particular. The one we really need is the one for return type, because if we can drop an argument, well, the return type by PHP standard is always there. There's always something returned. Even if this return is nothing, I mean, null. And that's how you end up with the void. Okay, so the argument may be null and return value may be null. But you have to end up with this paradox like when you ask mathematicians. So how big is the infinite? which by itself is already a weird question. And then the mathematician look at you and say, which infinite? Because there are several sides of them. Like, what? We have several sides of infinite? But here, we've got several sides of nothing, because we've got null. Remember, null means nothing. Everything is something except null, which is nothing. And then there's void. And void is something you return when you don't return anything, including nothing. So void is when you return absolutely nothing, you have no return inside the method. If you return null, you are returning something, even this something is nothing, sorry for the repetition, and then you cannot actually return void, you have to return something else. Maybe a nullable, but that makes a mess, so don't return null, just through an exception. Anyway, so we cannot use it for arguments, and generally speaking, we're going to avoid this special situation here, because we can very advantageously replace it with null pattern. Who's familiar with null pattern objects or null pattern class? Which is a design pattern whose objective is to get rid of null usage in general. No. Okay, so if you want to get rid of null in general, you have to use a null pattern class. So when we don't know, when we need a default value, in particular with object, what we do, we use null, because null can be written, null can be written as a default value, but then it doesn't do anything. Except that if you want to use this null later in an array, in an object syntax, to call a method, to call a property, well, null is really nothing, it's not even an object. It will just stop and say, okay, fatal error, I cannot access a property because you gave me null, and that makes no sense. So what we do is we actually create a replacement for null, that is an object that satisfies the same interface than the object we're trying to replace. So you imagine any kind of instance who has an interface, you create a second class with the same interface, but as much as you can, every method will do the minimum work possible. Which, when you think about it, is always very funny. I mean, you want to create a class, most of the time there's a lot of code in it, but this one has to be the shortest. It's almost like just a skeleton. Anytime you can, you return not null, but you return an empty string. You return a 0 if you know that this value will be used for addition. You return a 1 if you know this value will be used for exponentiation. You return an empty array if you're supposed to return a list. Which means that now this object acts as null. You can call it just like everything when you say, no, I don't do anything. You want what? List? Nothing? No, 0, empty string, whatever, everything. But you can still use it inside the code. And that's a very good replacement. Okay. In terms of development, I also use it as I call exception pattern. So if I want to use this null object, but make sure that anyone is using it really, I will put actually through, I will make it through exception anytime it calls. One of the methods is called. This way, I make sure that my code is just using it until it's replaced by something that makes sense. And if it's not, if it's used or tried to be used until there is a sense, then I will know about it. Two different levels. So we kind of skip, I would say, the null pattern that's just the Now, in terms of adoption, I was surprised that so little hands actually raised there. But maybe you're coming here to learn about design, typehinting before you actually do something. But 90% basically of PHP code nowadays use typing. It really has to be an old code base. Otherwise, there will be a few of them. Okay, so almost everyone is doing it. What this does not show you, because this is a really rough presentation, is the actual adoption. And this is the percentage of the code that is covered. Oh, we don't see the bottom of that. This is the percentage of the code that is of the parameters and the return type that are actually activated. Okay. And, well, you don't see that much, but that's still valid. Here, there's a quarter of the code that just like return one or two of them, nothing more. So, yes, they use typing, but like out of, I don't know, 11,000 parameters, there's like 2 usage. Okay, that's a beginning, but you still have some work, okay? On the other hand, I know the one that's 100% is cheating because it's a project with like one class and 2 methods. So yeah, that was easy to go that way, but no one is basically above 90%. That's like the limit at the moment. Even code base that have been completely rewritten from last 6 months, they use a lot of it, but they cannot reach the top. So don't try to break a thread and do 100%. We still need a number of things before we actually reach that level. The other thing that I find interesting in stats is this breakdown. So the different types of type hints, can you read that? Yeah. The different types of type hints have been gathered here. Classes is covering everything like classes and interfaces. Okay, and you can see that basically half the projects are using those kind of typing. This one is a special one. I just collected all the scalar type hinting into one. So you see that currently in PHP we are more using scalar type hinting than classes type hinting, which means that probably we're still at the stage that we're trying to move toward type hints, but the easiest way is just don't change anything and start using the typing where it's not dangerous for us. Okay? And back to the previous one, I can see like 3/4 of the population is all using less of 25% of typing. So it's still the beginning when it's easy just to add one, and there's like the method is called once anyway, so it's fine, don't bother anyone. On the other hand, I kind of expect there will be a few hurdles we're going to see in a moment that will prevent us to go on the last level. So let's move on. Current adoption. Inside the method, what is the impact of typing inside the method? How are you going to write code differently because you're using typing? And I would say if people go to reach typings is because you have far better checking than you used to do. Just look at this one. We are expecting an integer, and for some reason we are doing actually the check. So we have that. We have to do, if it's an ugly integer, then we throw an error, or we actually do the work. If we want to get rid of all that piece of code, which is both cumbersome, that people don't remember to put all the time, then we end up with just the typing here and one line. What is that? Just one of them. So it's really shorter system, shorter text, and it's just like a few letters you add in the argument, and it works all the time. PHP will take care of that work while it's executing. So far less work to do, but much better and more systematic usage. You should, if you want to do that move, you should check all those functions that you use to check the type. So this kind, or the check with null, and everything you're casting. Everything you're forcing into a specific object or type of object before using probably means you're doing some kind of check, but then just accept any kind of error and just use it by the way. Okay. The impact on checking is actually even more important when you're dealing with objects. So here is the same kind of function where we accept one user, but then we can get lots of things. We can get the null, which is already very special, and before we actually start using null, we have to make sure it's an object. So first a check on null, first exception. If it's not a null, then we have to use a user, and then we can start doing something. That time is a instance of, is a subclass of, equal null are all points that you should get rid of because typing will help you do the work for you. Far less work, so that's an interesting part of the code. Now, yeah, I end up with that once I just start using the right type. So far so good? Ah. Next, consistence. Consistence is what I call the Esther-Post syndrome. You've all been bitten by this bug, right? You know Esther-Post. Esther-Post will look for a string inside a string, and it will return you either the offset at which the string was found, or it will return false if it couldn't find anything. Except that in PHP, offset starts at 0. Okay, so people have been beaten, so I don't have to explain that more, right? So it returns 0. So if the substring you're looking at the larger string starts at 0, and you're just comparing Esther-Post with nothing, like false with the double equal, then the false and the zero will be kind of mixed, and you will actually skip a number of situations. Okay? So here, that's exactly what we have here. We try to have this function, we do something with it, but in case of error, we return false. And if people end up with an age of 0 for a newborn baby, then the newborn baby will be just confused with an error, and then that will be a problem. Okay? So if you move to typehints for the return type, or we're moving away from the argument, but now we're going to the return type, the problem is not people calling your function now. It's your own code that has to be consistent and only return one and only one type of information. Which means that we also now have to find another way to handle the errors. Maybe here with age you can return a -1 and expect people to do comparison until someone will say, okay, I will just take that as it is and start pushing it everywhere. So you will end up with ages that do not add up to the right value. That will be bad. But here probably you have to start changing your system and maybe move to exceptions or have your own property that will store errors until someone actually takes care of it. That's an important way of evolution. Self-consistence. Self-consistence will actually also kind of help you wonder who is going to handle the problem. Now, shell exec will return a string. So we could actually and almost type hint the return type of bar with string because, shell exec will return string. Except shell exec will not return a string, it will return a string or null. If something happens, then it will return null. So it's not consistent. It's actually ending us the work of deciding what to do if the shell exec fails. Here we say, oh, I don't know what will happen. I don't know what to decide if the shell exec fails, so I will just give that to the next one. Whoever is calling me will have to do the checking on the result. And if they fail, then it will just bubble up until someone says, oh, I get a null, I cannot do anything with that. So the self-consistency has now an impact on your code. You've got to think, am I always returning a string or not? Can I cover the problem and decide that, well, yeah, I'm going to return a string, and if it's not a string, I will make it because shell exec will fail in really rare or difficult situations, so problems will be away. Okay, I just can skip that and just make it consistent. Or no, I really want to have the error handled and logged, so I will decide that I will throw an exception and log it. That's up to you, but you're already kind of understanding you're handling problems to someone else or dealing with them inside the method. So from there, one of my favorite usage of typing is just debugging tool. If you don't understand why the hell you get an empty string into this very important function, just start typing things with string typing, string or typing. So here we've got different calls. Now we have the typing, and now ever since we have the type, then if anything is wrong, if it's not the expected type, we get a fatal error. As a debugging tool, very simple. Just run the unit test, run your test or your manual test until you get errors. Then you will know who has called you. Then go there, fix the origin, and try again. What happens with this, and it's probably why we have such a large percentage of the code base that are using 2 or 3 typing, is that initially you will find lots of those errors. Okay, so that's why it's a debugging tool. You put it, get lots of errors, fix a few of them, realize it makes your code better. Then you start getting those errors less and less, but still, and so you leave it there. And you don't know when to stop, you don't know when to remove it, so you just leave it there. And so it ends up in production. But it has been tested in between. Okay? So the first one, it will help you make sure that your data is consistent, it has been well tested before you actually start using it. If you do not feel safe by putting it in production, remove it before production and keep doing it as before. But as a development tool, it helps debugging a lot. Once you're done with just debugging it, so very circumstantial usage, when you start thinking, okay, I did that here, it helped me a lot, I want to do more. I want to make sure that the rest of the code is there. The average amount of typing you have to add is 11,000. It's an average, okay? So if you check Wikia, you probably are going to be close to 1 million different typing parameters. If you're doing, I don't know, smaller application, there may be more, 100 of them, but still you now have to review every single method and their return type to do it. And we're going to find a few words in the language. Anyway, so it's a lot of work. Static analysis will help you. Okay, if you're already using, for example, SAM, and I mentioned this one because the author of SAM will be there, I think, starting tomorrow, so we may see and meet him for questions. They will do some auto-detecting. They are able to look at the code and decide that, oh yeah, I know it's going to be a string, you didn't mention it, but then I can work with that. Exactly, you actually have, since yesterday, we have the first report that will help you decide that. Looking at the usage, I decided that you could safely say it's a string, and then, well, decide if you want to do it or not. What does it mean by based on usage? Well, often the arguments themselves are kind of relayed to other functions. In particular, the one for which we have the TYPEHINT is PHP native functions. So here, everyone know array fill? Array fill will actually help you create an array from 0 to here B elements with always a copy of the same element. So if you want to do the initialization of an array and not just have zeros instead of doing a for each, think about array fills. Very convenient function. But here we say array fill, we will do an array from 0 to B with the value C. B is yeah, not the float. On the other hand, the second one is a little more tricky, but we don't exactly know. The plus is ambiguous, right? The one tells us it's probably going to be an addition, but then the constant we don't really know, and what are we going to return? I don't know. So the second one is based on the calls themselves. We see that A, well, it's not actually used here, so the example is bad. But based on the usage, we see that all the calls of these methods is only on arrays. Then we can decide that, yeah, probably it's safe to put that as an array. And those are the simple situations where you actually learn how to decide what kind of style typing is there. Now, the thing is, automatic detection will actually end up choking on a few points, because the same array thing we've seen here is say, well, we call foo and we create an array of 10 elements of B. What can B be there? It could be anything. It could be a mixed. And at that point, as a developer, you know what you're putting there. Or maybe you want lots of things to be there, and then you cannot type it. We cannot guess it. Maybe as human beings, we cannot even think about it. And now typing is just not possible because there's nothing to type there. Everything is possible. We have no support for mixed. No typing is possible. Okay, so reaching 100% is probably the reason we don't have the last 10% there, because there are situations where typing is not yet possible. Maybe in 7.5, now that we are done with the properties, maybe that will help us, identify those situations and start building more syntax. Maybe for PHP 8, I don't know which will be the next version, but at the point we're kind of stuck. Same thing for return types. We've seen already shell exec. We cannot say it's a mixed element. And then there's a number of other situations. So sadly enough, there's like one major advantage, and all those situations are rare, but since they're numerous, they look like there are a lot of them. Okay, but just consider they are very unusual. One problem happens if you use function getArgs. Remember this one? With this ugly name, it's a PHP 4 function, so please do not use it. But if you have to, it allows you to have variable amounts of arguments in the method. If you can, and like 90% of the situation, you can do the upgrade using the variadict, which is the 3 times ... It will actually get anything that's beyond this argument into one array, and then you manipulate it as one. And that's most of the time the case. Like you have 1 or 2 specific arguments, and then after that, everything else is the same type, and will probably end up in an array and treated as a for each. Think a remerge, for example. So if you're using function getArgs, well, you'll have to do all the typing on your own, because you will get all the arguments, and based on the position, you will decide if it's an int, a string, or a class. On the other hand, variadict works fine because you can use the variable on the arguments and then say that it's all of them will be string. So the first call will be right because all of them are string. The second call will be wrong because they are different types. Everyone will be checked individually by PHP. It's not worth getting your arrays, spreading them, and then having PHP again fold them. It's just too cumbersome, so don't do that. Arrays. So arrays are going to be a pain, a real pain, because the array is a type. Okay? It covers lots of usage. It can be a list, it can be a hash, it can be an array, maybe lots of things. The problem is an array is a box. So yes, you get a box. It's written on the top of the box, it's a box of cheese, but maybe inside you just got angry bees. There's absolutely no check of what's inside. You just know it's a box and there's something in it. You can check it, you can try to open it, but you'll have to actually open it really and check everything individually to have it. Currently, there's a lot of debates about what we can do with that. There's no solution. Again, I'm talking 7.4, 7.3. There is no implementation. The solution would be generics, which will allow us to say it's an array of something. And then PHP should be able to say, okay, I get the array, but I don't have an extra check. I will go inside the array, check everything, and then tell you it's fine. At the moment, I think there are like 2 implementations, one in 2016, another one more recently, but it didn't make the cuts of 7.4, so it's not coming up. Apparently, there's a lot of discussion on how to implement them. The only one, again, that are a little in advance are static analysis tool, which may have implementation. I think PHP Stan is supporting them. So again, the author will be there. I thought he was arriving today, so I was expecting him today here. But he's arriving, so if you want to talk to him and have more insight on how to handle generics in your code with PHP Stan, then you can maybe Andre will be on the premise tomorrow and definitely on Friday as a workshop. So arrays, now yeah, you're stuck with the array itself, and there's nothing there to do. Another one where you may have problems is all those magic get and set. Because those are just like one entry point for all the properties to be sent values and then be associated. So on top of that, now on 7.4, we can make sure that the property itself will hold a specific value, so a type of value. But get and set, of course, well, they should be able to get everything, so it's not really possible to type it. If you really want, or if your situation allows it, then you actually can type it. So you can say, I got a set, and the A here is always an int. I don't know, I've got a list of prime numbers. I want always to be set with values that are ints. Then you can have A. Just for the fun, you can also type name as an array and expect PHP to check that the name of the property you're assigning is an array. Of course, that doesn't work, but PHP actually handles it, so just for fun. Anyway, and then, well, we've got multiple types. I'm sorry, that's a long list of things you cannot do, but again, maybe you're not dealing with all those situations at the same time. Multiple type, if you want to handle all those multiple types and doing the checks like that, you want to accept both integers and an array, then again you're stuck, there is no multiple. We had the multiple type for catch, so that worked for a while, but it seems it's not coming up in any foreseeable version of PHP. So just stay for catch. And here I actually want to spend a little time on that because there's a huge problem here. The huge problem is that you accept arg, which may be anything, there is no type-ins, and then we say, okay, if it's an array, if it's an integer, I will add something and then return it. Otherwise, I expect it to be an object. Which means that if I send a null, if I send an array, then it will pass the first test, and oh, it's not an integer, then I will actually try to use it as an array, and that will stop the whole show. Anytime you are doing typehint inside manually, you should actually type them explicitly. So if it's an integer, I do something. If it's this instance of an object, I know I can do the code, so I will call something else. And the final one should probably be a default value that's not taking actually any advantage or any usage of the incoming argument because we don't know what's that. We cannot use a switch because each time we actually have to do a call to a function, but then you end up with always those big ifs. Okay? And that's actually going to lead me to the second limitation of things that you may find in your code that should be upgraded. We mentioned earlier that the type-int should be a class. Well, to be precise, the type-int should be not a concrete class, it should be an interface. Because the thing is that with the evolution of the code, what you add as a class initially may become a second version later. It may be a mock object because you want to use that later as a test. It may be a new, well, it's already said a new version or a compatibility migration. And if you are actually type-inting against a concrete class, then whatever evolution this class has will have an impact on whoever is using the class or extending it. The best way is actually to create an interface and make sure that the type-int actually is made against the interface, for which you have a number of implementations. And you can add always a third or fourth new implementation and still ship it to this method and get the result you expect. You do not depend on the previous code or extend it. On top of that, I have to remember you that interfaces themselves can be extended. Meaning that the interface, if it's not sufficient at some point, well, you can have extra methods that change them and end up with something that's really evolving with your code. You will see that a lot, like do not type-int against a class, but type-int against an interface. That said, you will end up with problems like that. And there are actually two problems in the same code here. The first one is kind of easy. We have an interface here with a foo function, and then we have the type-int here. Oh, there's a class. We don't care about the implementation, but if the code runs, then we've got the foo definition sufficient for us. We call it here, but then we're doing the call also of the property P. How is the property P enforces in this piece of code? Never. Interfaces will enforce that we actually have a foo function, a foo method actually, but not a P property. So the interface typing here is not sufficient. It will only check the methods and you say, oh yeah, you have made ABC, that's fine. But then you're asking for P. Oh, I'm PHP, so I will take a look. Oh yeah, this object has a P, we can go on. But there's no checking on the property itself. The only way you have to make the property available would be to have a class. Oh yeah, I have to change my size. No. The other point we don't really see, oops. The other point we're going to see before we move to the solution is that the interface will only check the object that it trans. So if you have foo here, well, here we're using foo method, that's fine. But if we also decide to use a property or an extra method that's not part of the interface, PHP will say, fine, if I find it, I will use it. Type-inting only applies at the signature level. After that, you can do whatever you want with your object. So it's kind of a weak verification. Now, for the property, am I going the right way? No. There. Property, well, I have to push you back to the class. Either you make setters and getters for all your properties, so you avoid using properties in type-int and methods. Maybe you don't like setters and getters. Okay, then keep the property itself, go back to there, and do not make a concrete class, just make it an abstract class. So you can have several versions that will be available so that you can use them, and in the same time enforce the fact that there will be this P function or property available all the time. Good enough? Anyway, I think we're good for the inside of the function. We're going to start the really hard part. The systemic impact of typing. Because what we've seen here is very nice. I mean, we are inside our curly braces. We decide that anything that's coming in, we want an integer, and whoever is calling us has to give this integer. So we're kind of pushing the problem back to someone else. You don't like to send me an integer? Fine. Fatal error, and we still stopping the errors. That's not exactly going to be good. As a system, we are going to have things, calling each other and using the wrong type. That's going to be wrong. So let me start with something very simple, just to start giving you an idea of the problem we have here. This is very abstract, but this is a framework. Stay with me a moment. This is a framework which has a certain number of classes, but the classes are only available through 3 methods, M1, M2, and 3. As you can see, someone worked on documentation. It's extremely clear. Right? So it's a very special framework at the moment. We will make it more real later, but I want to use it so it's simple enough and you understand the different impact of TYPEHINT in the code. Okay? We have 3 functions, no precondition. We can use any of them at any time. And if they do, they will provide us with classes which are not represented here. Weird, but workable? I'd like a yes or no, please. Okay, so 3 functions. How do we use that? How can we use this framework? The naming is not even readable, right? If we had like create, delete, update, then at least we could read that, and with our high level of English, we could decide that, oh yeah, I have to learn to code first create, then I can use update as many times as I want, and then I do delete. Or I can just create and delete and skip the update. But I already get some documentation. I would need the manual itself to understand which way I have to order that. Is there an order? Is there something that must be first? I have to do something at the end? Just looking at the names there, we're completely stuck. We could actually try PHP way, like call them one after each other until something do not break a fatal error. We have no idea how this works. Let's take a look at how it works if we get some typing. The execution, if we have any, is from the top, so the arguments are little squares at the top, and what we get is the result at the bottom. Here we are all typing, strong typing everything, so we can see what we have here. The first one is called without arguments, or very scalar arguments, so we can just randomly create them and ship that to the function. It will give us a blue class. And then the blue class can be reused, or we can create several of them, and then push them into M2 to get another type of class, which is now the red class. And then the red class can be again fed into M3 and then get a pink class. Do we need more documentation now? No, it's there. The typing here is giving us the order in which we have to execute things. What will end up is a result like that. The typing, even if we don't think about it when we're doing that, we are changing, we are creating a precedence, we are creating a priority, meaning that we now have to call it necessary M1 before M2 and then M2 before M3. Does that ring a bell? Do you know any situation, a native PHP situation, when we have that situation happening? Classes or functions? I have both examples. When you want to query a database, what do you have to do?
PDO object and change.
You create the PDO object. What do you need for the PDO object? The DSN. We feed it with just a simple string, and we can try any string we want until we get what? A connection. Then we get the connection, we feed in the query, and we get the statement. Then we get the statement, we don't give it any argument, we just call it again, maybe configure it, and then we get results. This is exactly the way it happens. You cannot actually get PDO result before calling the statement, before calling the PDO. If you haven't tried that, can you instantiate a PDO statement out of the blue? Have you tried? Come on, if it's a PDO, maybe you don't use PDO, but if it's a PDO statement, why can't you just say, okay, I want the PDO statement, I give it something. No, PHP will actually yell and say, you cannot instantiate PDO statement. There is a specific error message in PHP for that. Another one that's based on functions, closer to our example, would be any file work, or anytime you use a resource. fopen gives you the resource. You use the resource to call fwrite, fget. When you're done, fclose. Again, we've got them in order. So that happens already. We already have that, except PHP will just do it as it happens. Oh, yeah, you're trying to close a file that's not open, fatal error. Are we good with this first example? Because I have others, but I want to make sure that you understand the first premises of the problem we're raising here. Easy? Yes. Good. Let's take a look at another situation. What is that? What is that? We still have the same functions, we just change a little bit the typing, just the colors. We know of M1 that's still outputting the blue class, but now M2 and M3 accept this class. And they will both provide us with different results. Remember, we have no idea what this framework is doing. What kind of pattern is that? Can you imagine that kind of situation? Yeah, that's me. Yeah.
Could be some kind of conversion framework that converts the blue ones into the red and pink ones, so kind of generating an XML output or a JSON output depending on what you need.
Completely. You've got one input, which is very wide in terms of argument, because you can get, I don't know, file or stream or database or something that gives you an internal representation, and then the internal representation is given to something that will be another standard, and you turn that into YAML. That could work. In the execution of the application, what kind of situation does that represent? Something that you start at the beginning of the application and then you use all the time before doing anything else.
With a config.
Sorry?
With a config.
Yeah, config, or a container. Something that initially has to be available to everyone. When you start and you bootstrap your application, you start with nothing. You cannot imagine your application starting with at least one type int, because, well, except for scalars. Because if you start with a class, then everything is blocked. But here we start first one and we call this thing that will provide us with the config. The config now is available, and I can use the config as a base to create the first database, the connection, the FTP connection, and then something else, and then I will have the object interact together. But I have this first step where I have M1 doing the work for the others. Yeah, more a bootstrap system or container. This one is introducing something special. This one is not from an established system, but that will probably happen as you're trying to put new typing everywhere. What do we have compared to the previous one? Well, we've got less classes. We still have M1 we can call anytime, but the two others are calling each other. We now are having a cycle, something that says I cannot call M2 before M3, but I cannot call M3 before M2. And thanks, we've got M1 that allows us to break the cycle. That will happen when you start putting typing, because you will put them one after each other. Okay? So you may start M2 and say, oh yeah, I have M2, but I need the config, so I have to call the config. And the config will say, yeah, I can have the config, but I need the database connection. Oh, the database connection is coming back. So I have to go back to the database connection, but the database says, oh no, I need the config. And then you're stuck. Until, well, we'll actually end up again with the null pattern. The null pattern will allow us to start breaking that kind of things. We'll actually have, the null pattern will say, okay, that's an object, it won't do things, but at least it will say, oh yeah, well, we will have a connection later, so there you can do something, give me some more information, and I go back. This will probably not be something settled in your code initially. That will happen as you start putting things. And initially putting the typing will be fine, until you end up a moment where you try to break or make a cycle, and then you realize that everything stops. And usually, if you don't have a null pattern system, you will have at least to break one of the two. One of the class will have to be instantiated before the others, and from there called again from the first one, so you've got the full initialization. You probably have a big code smell somewhere in the code. But the fun part is that now we can actually detect it from the outside. We don't have to look at the method and try to guess whose has to be before the other. We can now actually take a look at that. Let's move on. Can we see other impossible situations using TYPEHINT? Well, obviously this one is impossible, right? everyone depends on M1 and M1 depends on itself, so we're stuck. That's not going to happen. Can we do something more? Is this impossible solution harder or easier to spot? Well, actually, I told you that there was an impossible solution, but here we actually see the dependencies, and again, we're going to see larger cyclic times. If we have more classes, then maybe that kind of cycle will appear, and that specific ring of classes will not be available without some external influence or external code. So we may end up with a dead end this time. There are not all situations that are available to us. We've got to be careful. So we're going to ditch this small framework, and we're going to introduce two extra elements. First, classes, because we were working with functions, so we can call them anytime we want. But classes are going to add an extra twist, because what we have as a result of a typing may have extra dependency on the classes. So we're going to check that, and we're going to see what happens when we check that on real applications. So here is the representation of the previous framework, or at least a part of it, if we actually add a class. What is the main difference if we introduce the class as a real element of this ecosystem? We still have our function, that was called M because it was a method, so I guess you got that. But to reach M, we don't just need one argument. We also need to call the constructor. The constructor will always be called anytime we do a new and calling the constructor is exactly the same. Both of them will take arguments, and those arguments will pile on each other to actually allow us to call M1. It's just very simple for us. We don't see that, but anytime you want to call M1, you actually need two classes now. The one for M1, the one from the constructor, because you cannot call M1 without the constructor. First impact, it tends to make the code a little harder to update. In particular, if you're starting to type in, initially nothing is typed in, so no impact. But then you've got, probably like everyone, extensions. M1 from C2 overwrites M1 from C1. So what happens if we decide to change the argument, or change the type it, or maybe add it? What is the side effect? What does PHP like to do? It will check that the signature, arguments, number, and typeint, and default value are the same on C2 and on C1. Meaning that if you decide to change something on M1 here, you also have to change it above. And I think you can imagine what will happen soon. We will get the Christmas tree. If I want to change something in C2, then I will have to update C1, but C1 has also 3 children, so I have to check now 4 classes, so 4 methods to update all the typings from all the classes. And then I have to go up to the grandparent, which also has another class, depending. Every time I update this method, which is heavily overwritten, I will have to change 6 of them. So maybe typing will be fine when you start adding it, because it's the moment where it's fun, but suddenly you realize that there will be like big steps. Remember this evolution of people using more and more? There are situations where you will be at 35%, you hit one of those, and you have to fix all of them at the same time, and you'll go from 35% to 40 because you're going to change lots of methods at the same time. And that will probably step on other people's methods and code. So that will be probably a break or a slowing, something that will slow down in the adoption. Now let's move on because we're getting close to the end. Let's go back to our definition. The constructor itself imposes us some extra arguments, but we never call it by itself. Right? We know at some point we'll have to do a new, get the value, and that's it. So we can actually replace this representation by that. Calling M1 means calling the argument for the constructor, and then adding the argument for the method itself, and then just getting the last one. Fair enough? Just a representation. Meaning just from this one, again, we're just having one method. We have an order in classes. Remember this dependency we were working on initially? Now we have, just from this class, we have the C5, well, I get the name, but the blue one depends on 2 other classes, And the last one, again, depends on the first one. So there is now an order. We are moving from just giving links between methods. We are now having interaction between those methods. They're not just things you can call in any order like we have with our small framework initially. Those functions, whatever order it would work until we get a fatal error. No, here we see this order. This is literally called a topological order. We have other topological orders in PHP, right? Everything about inclusion, remember? Inclusion, you have one file include another one, and the other one include the other one, and then at some point you end up with the same problem, which is that if you include a file that includes the first one, then the functions or classes that were already defined will say break, it's already defined. We've got the same kind of problem here. So the third part here is if we have a PO and OP project, we can actually take a look at it as a general result. So I took the previous topological order and applied it to a small framework. I think it was called Buzz. It's pretty small, let's say 100 classes, and those kind of arrangements on our queuing. And we start looking at things that we've already seen as with our small framework. Here, TCPDF, for some reason, is using QR code and other intermediate classes. If we want to learn this framework or this application, TCPDF is our entry point. We can simplify the learning of this application by just learning that, because we understand now that those are dependencies. They are things that are being used by the main class. We don't need to know all the details. This is like one package. You can see the other one here. We've got a bunch of classes that are all producing the same type of class. That looks like CQRS to me. I've got an event. The event has different name. Can you read that? Process invoice, account model, charges. They all produce one line that will update the ledger. And then this can be pushed to the bus or to the queue so that it will be processed in order. We already understand a little more the organization of this application. Here again, HTML to PDF is there. It has a number of secondary classes, including the exceptions. All of the classes are using exceptions. That kind of makes sense. But we're not stopping there. We don't have to learn HTML to PDF because we have a common class that will deal with creating this object and manipulating it. Maybe we should just learn using common, and that will be all for us. We don't have to go into details with HTML to PDF. Someone took care of that. I have no room for this one, but I gave a try on Symfony. So I probably would need, the other room and another 15 meters on the other side. But this has 4,000 classes. It works. So I get a topological order. I get the number of classes that are next or before the other. So there's something there. But for really large application, it's still not convenient to take advantage of those. Maybe if we can focus on a specific namespace, on a specific class, we could grab information. But for large application, it's still not good enough until we get a better visualization. We just know it works. Oh, that's interesting. Finally, just to try to think a little beyond what we have, and again, that's pretty much research work at the moment. Based on the TYPEHINT, we could actually start thinking about methods as just a group of arguments. Look at this one. Do you make any difference between MC1, MC2, and MC3? The first one says, if you want to create the green class, you need three different arguments, which are asked at the constructor time, and then you call MC1, you get it. The second one will require only two arguments at constructor time, the third one at execution, and still give you a TYPEHINT. The last one will actually use something different, and probably it's more 7.4, because it will just create one with the blue, another one with like a setter, so you can change a property along the way, store it in the class, and then when you call MC3, then you get your final result. Are there situations like that where you can feed the same function method with the same argument and get different results? Well, that exists, right? There's a number of situations. So that is not going to be completely systematically the case, okay? I can give you like the different side of the triangle and ask for different results also. Okay, so still feeding the same argument, just getting different results. So it's not going to be systematic. But now maybe if you think about code reuse or different ways to achieve the same result inside the framework, just looking at the arguments that are fed into one of the methods and the result they give will allow you to say, oh, this part of the code is actually duplication of the other part. It's just very different organization, different sequence. We don't get the same value at the same moment, but we still reach the same result. There may be something that can be federated or centralized at that point in the code. So more insight and maybe more interesting review of our code for the future. So to finish, and I think we're just on time, well, it helps a lot. It helps a lot to have use static. To use static hinting. It definitely have an important impact in the code. And I would say it will probably be easy for the first 25%. It will suddenly be really harder when you start from 25 to 50. Once you've made that leap, then you probably finish the rest of the typing because you've cleaned and made the topological order and everything is fine. There's still a lot of innovation coming in PHP. If you're interested, I don't know, generates variable with the typing, other things we've mentioned. Well, try to make yourself known at the PHP group or in bugs or in any discussion that's available, and try to say, okay, I would like to use that, and maybe we should push that for PHP 7.8 or 7.5. I would also say that if you're just doing quick and dirty stuff, well, that's not needed, okay? That will happen at the moment when we start to think, okay, I have to debug, so I will start putting a few bits, a few typings in the code, and then that's probably the good moment for you to decide, yeah, I will be trying to put more everywhere. For those of you who are interested, different tools that are using currently static analysis and typing, so you can check them later. I also collected the warnings, but I don't remember why, so we'll just finish with that. Thank you very much.